Hi everyone, in this video we are dealing with fractions. Let's see what's the definition of a fraction. Fractions represent the parts of a whole or collection of objects. Suppose there is a certain object and we have to represent a part of this object, we can use fraction. Or there is a collection of similar objects and we have to represent a part of these objects, we can use fraction. For example, suppose there are 10 books and we have to represent 4 out of these 10 books, we can represent it using fractions. A fraction has two parts, numerator and denominator. It is represented like this with a line. The number above the line is called numerator and the number below the line is called denominator. The denominator denotes total number of equal parts of the whole or the collection of objects. And the numerator denotes how many equal parts are taken from the total number of equal parts. You might have seen this type of representation in answer sheets of examination like this, 9 out of 10, which means the total marks was 10 and you scored 9 marks out of 10. And let's see more about fractions. Let's learn more about fraction of a whole. Suppose there is a cake which is a round in shape and it is divided into two equal pieces. Okay, and each piece of this cake can be represented as 1/2 of the whole cake, because there are two parts. It is written as the denominator and each part can be written as 1/2 of the cake. And if two pieces are taken, we can write it as 2/2. And it means 2 divided by 2, we can write it as 1. Okay, 1/2 is called half or 1/2. Suppose a cake is divided into 3 equal pieces like this. Each piece of this cake can be written as 1/3. There are 3 equal parts of this cake, which is the denominator of this fraction. This can be read as 1/3 or 1/3. Okay, if 2 pieces are taken, we can write it as 2/3, and 3 pieces are taken, we can write it as 3/3, and it is a whole, it is 1. If a cake is divided into 4 equal pieces like this, each piece of this cake can be written as 1/4 of this whole cake. Okay, because there are 4 equal pieces of this cake and it is written as the denominator of this fraction. It is read as 1/4 or 1/4. If 2 parts are taken, we can write it as 2/4. If 3 parts are taken, it is 3/4. If 4 parts are taken, it is 4/4. It's the whole, is 1. Let's learn more about fraction of a collection of objects. Here I have drawn 6 similar stars. So total number of stars is 6. So the denominator of the fractions that I will be writing further will be 6. If I take 1 star, it can be written as 1/6 of the total collection. If I take 2 stars, it can be written as 2/6. If I take 3 stars, it can be written as 3/6. If I take 4 stars, it can be written as 4/6. If I take 5 stars, it can be written as 5/6. If I take 6 stars, can be written as 6/6, which is equal to 1, the whole. Next we can learn about different types of fractions. There are 7 different types of fractions: proper fractions, improper fractions, mixed fractions, unit fractions, like fractions, unlike fractions, equivalent fractions. We can see definition and examples of each of these. First of all, proper fractions. A proper fraction is a fraction where numerator is lesser than the denominator. Example, 1/2, 2/3, 3/4, etc. In all these fractions, the numerator is lesser than the denominator. We can take the example of cutting that cake. We have taken that cake and cut into 4 equal pieces. If 1 piece is taken, it is 1/4. If 2 pieces are taken, it is 2/4. If 3 pieces are taken, it is 3/4. All these are proper fractions. Next is improper fraction. The general definition of improper fraction is as follows. An improper fraction is a fraction where the numerator is greater than the denominator. For example, fractions like 7/2, 11/3, 15/6, etc. are examples for improper fractions. We can explain this using the cake cutting method. Suppose there is a cake and we have cut it into 4 equal pieces. Suppose there are 4 friends and all the 4 pieces have been consumed by these 4 friends. Okay, all the 4 pieces have been consumed. So the fraction we get 4 by 4. And now a 5th friend joins them. Okay, and we have to take another cake, similar cake. Okay, and it is also cut into 4 equal pieces. And this 5th friend takes one portion of this cake and he takes 1 by 4 of the same cake. These 2 cakes are similar, same cakes. Okay, so the total number of pieces consumed by these 5 friends will be 4 by 4 plus 1 by 4. We can see addition of fractions later, but here we can add this as 5 by 4. See, this is an improper fraction. Here the numerator is greater than the denominator. Next is mixed fraction. A mixed fraction is a fraction that has a whole number part and a proper fraction part. You might have seen in answer sheets marks like this, 23 1 by 2. Here this is an example for a mixed fraction. 23 is a whole number and 1 by 2 is a proper fraction. Let's learn more about mixed fraction using the cake cutting method. Here we consider the same cake that was consumed by the 4 friends. That means all the 4 pieces got consumed and the 5th friend got 1 piece from the second cake. So the fraction of the first cake was 4 by 4 and the second cake it was 1 by 4. Here we can write 4 by 4 as 1. 4 divided by 4 equals 1 and here it is 1 by 4. The whole fraction can be written as 1 plus 1 by 4 which is equal to 1 by 4. This is a mixed fraction. Next category is like fractions. Like fractions are fractions that have the same denominator. Next category is like fractions. Like fractions are fractions that have the same denominator. This is a Next category is like fractions. Like fractions are fractions that have the same denominator. These are a group of fractions. For example, 1 by 7, 2 by 7, 3 by 7, 4 by 7, etc. All these have the same denominator. These are called like fractions. Next category is unlike fractions. Unlike fractions are fractions with different denominators. These are a group of fractions with different denominators. For example, 1 by 5, 2 by 3, 3 by 11, etc. Next category is equivalent fractions. Equivalent fractions are different fractions that represent the same portion of the whole. They look different but have the same value. Equivalent fractions are fractions that represent a particular fraction. They all have the same value. Equivalent fractions can be found by multiplying both the numerator and denominator by integers. To find equivalent fractions of a particular fraction, we have to multiply both the numerator and denominator of that fraction by integers. That means counting numbers and negative numbers. Let's see examples of equivalent fractions. Let's see how to find equivalent fractions of the fraction 1 by 2. So to find equivalent fractions of 1 by 2, we have to multiply both the numerator and denominator by integers. First of all, we can multiply numerator and denominator by 2. We get 2 by 4. Okay, 1 by 2 equals 2 by 4. Next, we can multiply both numerator and denominator by 3. We get 3 by 6. This is equal to 3 by 6. We can multiply both the numerator and denominator by 4. We get 4 by 8. This is equal to 4 by 8. We can multiply both the numerator and denominator by 5. We get 5 by 10. Okay. Like this, we can write infinite number of equivalent fractions of a particular fraction. Another example is 1 by 3. We can write equivalent fractions of 1 by 3. 1 into 2, 3 into 2. We get 2 by 6. This is equal to 2 by 6. 1 into 3, 3 into 3. We get 3 by 9. This is equal to 3 by 9. Again, 1 into 4, 3 into 4. We get 4 by 12. This is equal to 4 by 12. Again, 1 into 5, 3 into 5. We get 5 by 15. Like this, we can write infinite number of equivalent fractions of 1 by 3. The last category is unit fractions. A unit fraction is a type of fraction where the numerator is 1 and the denominator can be any whole number other than 0. In this type of fraction, the numerator is always 1 and the denominator can be any whole number other than 0. Examples: 1 by 2, 1 by 3, 1 by 4, 1 by 5, etc. 1 by 1 is also a unit fraction. Now I am sharing a bonus point. If in a fraction the numerator is equal to the denominator, this type of fraction is called improper fraction. So that's all about basics and types of fractions. Hope you all have enjoyed learning. The next topic is finding place value of digits in a number. Let's see the definition of place value. The place value is the position of each digit in a number. In a particular number, each digit has a certain position. This is called the place value of that digit. In Indian system of numeration, the place value of digits is determined as ones, tens, hundreds, thousands, 10,000s, lakhs, 10 lakhs, crores, and so on. This vary according to the number of digits in that number. Let's see how. If the number is of 1 digit, it will have only ones. If the number is of 2 digit, it will be having ones and tens. If the number is of 3 digit, it will be having ones, tens, and hundreds. If it is a 4-digit number, it will be having ones, tens, hundreds, and thousands. This goes on. Let's see examples of finding place value of digits in a number. Consider number 432. We have to find the place value of each digit of this number. We have to find the place value of 4, the place value of 3, the place value of 2. Let's see how to find it. Okay. First of all, we have to write, this is the 3-digit number, so we have to write this ones, this is tens, this is hundreds. So the place value of 2 in 432 equals 2 into 1 is equal to 2. Next, the place value of 3 in 432 equals 3 into tens, 10, that is 30. Next, place value of 4. Place value of 4 in 432 equals 4 into hundreds, 100, 400. Okay, we have got place value of each digit in this number. It is important to know the place value of digits in a number to how to read the number. Suppose we have got a larger number like this. This is an 8-digit number. We need to read this number. For this, we need to find the place value of each digits. We write ones, tens, hundreds, thousands, ten thousands, lakhs, 10 lakhs, crores. Okay, so how to find place value of each digit of this number? First of all, place value of 1 into 1, we get 1. Place value of 2 into 10, we get 20. Place value of 3 into 100, 300. Place value of 4 into 1000, 4000. Place value of 5 into 10,000, that is 50,000. Place value of 6 into 1 lakh, that is 6 lakh. Place value of 7, that is 7 into 10 lakh, that is 7 lakh. Place value of 8, 8 into 1 crore, that is 8 crore. Okay, so how to read this number? We can read like 8 crores 76 lakhs 54,321. Like this we can find place value of any digit in any number. The next topic is time. Let's see the definition of time. Time is the ongoing sequence of events. A certain number of events will be taking place in a particular order. This sequence of events is called time. It includes events that happened in the past, that happens in the present, or that are going to happen in the future. Time includes events that are going to happen in the future, that are happening in the present, and that had happened in the past. Time can be measured and represented as numerals along with a unit. Time can be measured and it can be represented using a number along with a unit. The units of time are hours, minutes, seconds, day, etc. Year is also a unit of time. These are the most commonly used units of time. 1 day equals 24 hours, 1 hour equals 60 minutes, 1 minute equals 60 seconds. Next, let's see how to read and solve a word problem. Here we are taking a simple word problem that involves addition. Here is a question. Mary has 14 crayons. Her friend gives her 8 more. How many crayons does Mary have now? When you get a question like this, first of all, you have to read it thoroughly and understand what it means word by word. Here, the first sentence says, Mary has 14 crayons. A girl named Mary has 14 crayons with her. The next sentence says, her friend gives her 8 more. Mary's friend gives her 8 more crayons. How many crayons does Mary have now? The question is to find out how many crayons are there with Mary now. Okay, so the operation to be done is addition. Add what? Add 14 plus 8. 14 plus 8, we get 22. Okay, we got the answer. Next, we have to write the steps for this question. Let's see how. First step. Number of crayons Mary had. Initially, Mary had 14 crayons. That we have to write in this step. That is 14. Next, her friend gives her 8 more. The step is number of crayons given by friend equals 8. The next step is total number of crayons. Total number of crayons Mary has. We have to show addition. 23. Okay. Like this, we can write steps for any word problem. So it's time to wind up this demonstration session. Hope you all have enjoyed learning through this video. Thank you. Have a nice day.